Alright, let's get started. So, this video topic is about test stability. Why it's a problem, why it matters, and what we can do about it. So, a bit of an agenda. We'll start with the problem. I'll try and frame why this is a problem and where it comes from. We'll talk a little bit about the impact, how to measure it, and also we'll look at some solutions to some common problems. There's no silver bullet. There's not one thing that makes tests not stable or flaky. Right. So, what is test stability or instability, and where does it come from? So, it's the chance of getting a false positive from a test or CI. So, it means that the test will fail, but the code's still okay. So, this is essentially the false positive. So, this is more common, I find, in UI tests, tests that need more infrastructure or have more moving parts, like end-to-end tests, and also sometimes tests that aren't properly isolated. And this becomes common, sometimes when you're testing websites and you've got parts of the website that you need to build that reach out to CDN, or sometimes even third parties for assets that they need. So, an example of a flaky test in a UI. So, a web browser makes a lot of requests to build a page. And those requests, sometimes, if they're going to a system under test, that system under test will then make multiple requests for information that needs to be assembled together to create that page. And some of these requests may even go to the internet. When we're talking about sometimes JavaScript assets or images or things like that. And so as you're running your tests, if you're relying on infrastructure like QA or staging environments for your tests to run, sometimes they go offline. Sometimes someone might be patching it or deploying something to it. And even if you do have blue-green deployments, you still may run into issues where your pre-warming takes a while, or your warming takes a while because you're not pre-warming. And these issues probably will go unnoticed because in production, stuff that isn't properly pre-warmed warms itself pretty quickly because the hardware is a lot bigger. But in staging and QA environments, warming becomes exacerbated because we generally have less hardware. And these problems become more predominant. If a bunch of requests from your test take an extra 10 seconds to execute because of they're waiting for something to get cache to get warmed or something, then it's probably going to cause some timeouts and your test to fail. That's the problem that we're talking about. So why the infrastructure causes a problem? So staging and QA systems generally don't have the same support as production systems. So, when they go offline and things like that, the team that's maintaining them, they probably don't have SLAs on them. If they do fail, yeah, sure, the team's like, we're in sprint planning right now, so you'll have to wait a while. So these are some of the problems that we have with using these for our tests that cause instability. We can also do things like maintain copies of downstream systems for ourselves to become more reliable as you start to scale out. This is a bit of a hairy or a bit of a rabbit hole because you may get to the point where someone says, hey, we need to stand up most of the company to test our systems, which can be problematic if you're having to stand up an insane amount of servers to run end-to-end tests. You can use things like Kubernetes to help with this, and it does help. And this is where I'll just take a tangent to talk a little bit about how ephemeral infrastructure is a good solution here, but not a savior that a lot of people use. So ephemeral infrastructure, if you're not familiar with the term, it's a computing resource that is created and destroyed dynamically rather than being present and long-lived. Where this helps is that it's not only about the consumption of resources, but also about configuration drift, which becomes a problem when you have to maintain large amounts of servers. So when we have running systems that exist for a long time, they get patched, config gets changed, and their state slowly changes over time. And this leads to state drift. and you end up with inconsistent behavior between the servers, and it becomes very unmanageable at scale. So if you are having to maintain multiple copies of backend APIs for different consumers, this will definitely help. An example would be if, in this example, with our 3 staging systems we're using for our system under test, we could stand those up in a Docker Compose. Every time we run the test, we're standing them up and then we're destroying them at the end, and this will become a very stable environment that'll be a lot more manageable. You could also do this with Kubernetes if you need more scale. You can stand up databases and dependencies and stuff in here too. It becomes quite nice. Why not just use production? You can, but if your application is primarily or solely read-only, then sure. I mean, it's just use production for your dependencies. We did this at scale with one of the big systems I used at Agoda for years. We started off with a huge problem with QA environments. We had 1 to 2 per team with about 30 teams. Each team maintained and manually updated their own config and their QA environments. So the config for the website we're working was insane. It was about 5,000 or 6,000 lines of code broken up into multiple files. We moved the whole management of the dependencies with the web config file to Octopus and started deploying everything to pre-live environments. And we also set up some cool stuff, like we had a branch name DNS convention where, you'd always get branch name.www.agoda.com as the an up-to-date version of the thing that you're working on. And if you're doing things that write data, though, it's hard. Like if you're working on things like payments, this becomes really problematic. If you do run a white label, though, and you have sufficient data fencing, you can make sandbox environments in production with your white labels and use this potentially. Is another common practice for using production as a test. I used to do this at my old company when we were working at Oztix, and it worked quite nicely. You do need to be careful when adding data from automation tests that are testing on production. There was another company I was working with where we ended up with a table that had 2.6 billion rows in it, and 2 billion of those rows were test data. So if you are using production and you're writing data from automation tests, be wary and beware of the data that you're adding and that you can clean it up. So how to measure testability? How do we know the impact? So what we generally do is we run our tests on master on a regular basis and look at how often they fail, right? Because your master branch or your main branch should always pass, right? Because you can't merge before the tests pass. So by following this, what we end up with is this measure of the percentage of chance that you'll get a false positive in CI. Because the percentage of failures you get on master is going to be equal to the percentage of chance of failure of a false positive. So we scheduled runs on master, and generally at intervals ranging from 30 minutes to 24 hours, depending on the frequency that the application's contributed to. So there's only a few applications that would run it at 30 minutes that are the really high volume sensitive ones. But most of our systems are like, 6 hours, or every hour we run the pipeline on master and just check how it's going. So we look at the whole CI pipeline for a system, not individual parts or tests. The reason for this is I've seen so many people fall into this fallacy before where they go, hey, my team owns this job in CI and our tests are 99% stable. Yes, that job is 99% stable. But if all of your 20 jobs in your CI pipeline are all 99% stable, then your actual stability is 80%, right? Because if there's a 1% chance of every job failing, then that's not a 1% instability, it's 80%, right? And another way of saying that is it's a 1 in 5 chance of getting a false positive result from my CI, which tells a very different story, because that means 1 in 5 times when I run CI, it's telling me that my code is wrong and I'm investigating it and it's not, and I have to rerun it. Also, you want to measure these things close to the developer experience as possible, right? So having a look at the actual CI pipeline holistically, that's what the developer experiences, the whole pipeline, not the individual test jobs. So some solutions to the common problems. So, one of the worst solutions for test stability is retrying tests. And this has become a common thing that's been implemented in a lot of test frameworks and even CI systems, in the past decade, which is a bit sad. I would avoid retries at all cost. They are like crack. They are addictive. Once you start putting retries in, what it means is you then make it easier for more flakiness to get into your system, right? So, just adding one retry means that a test that fails 50% of the time is likely to get into your code and then start to cause problems. And once you add one, you'll start adding more. So the best thing to do here, my advice, is to be a purist and don't compromise. The alternative to retries, what is it? What we do is we investigate and monitor CI stability. And I think this is a fair statement because your pipeline is a part of production. It's your path to production for your code. So you should treat it like production. We monitor alerts on master stability only in business hours, though. Like, I don't have people getting called at 1 a.m. because the pipeline suddenly starts failing on master. But people do get called in business hours, and we react to these problems immediately. You can see here, this is an example of an incident we had. This was over New Year's, but when people get back in the office, they react, they start fixing it, and things get fixed. Now, the reason that we're aggressive on this is because if you catch a stability drop, generally it was the last merged MR that caused the problem. And you can revert it, right? And then you can go to that person, hey, this makes the things unstable, you need to deal with it, and then immediately things get back on track. If you start adding retries in, these problems can fester. And, you'll get things added that cause problems that aren't as present because they aren't as visible. So, but what if you're already in retry hell and you're up to 4 or 5 retries on every test? What can you do about it? So, don't worry, I've been here before. There was a large monolithic application that I worked on years ago where we had this problem. We got up to like 4 or 5 retries and we got out of it. So it's important to understand which tests are retrying. So in this simple example here, we have test 1 that, failed 3 times, and then on the 4th time it passed. And then test 2, it passes straight away. Test 3, it passes, and the first time it fails. So in this scenario, this is what you want to start tracking, right? What we did is we basically either wrote wrappers or extended the testing frameworks that we're working with. You can see below to do the retry implementation. But then from that implementation, what we did is we pulled this data out to know how often things were retrying. Because the retrying in most of the test frameworks, not all of them will actually report the number of times a test had to run before it finally passed. So this is what you want to focus on, because if you can get this data out, you can start to focus on the tests that are retrying more, increase their stability, so you can then overall start to reduce your retries. And by doing this, you can set alerts on tests that are taking too many retries and address them nearer to the cause in a similar way that we're talking about overall pipeline stability. And you can get reporting to help teams look into existing high retries. I mean, a lot of this implementation stuff that we did, it was just sending data either directly to Elasticsearch or sometimes the REST endpoints, simple APIs that we built to, shoot stuff through our data lake and just analyze it afterwards. So it's a long and lengthy process to get out of those. So if you're in this position where you've got heaps of retries, start today, because it's going to be a long road out. Waits and sleeps are another common cause of problems, and also the sleeps I generally find is they're patching issues that have got other underlying causes. So a good common example is waiting for dependencies to start. I see heaps and heaps of sleeps in bash scripts. The better way to handle it if you're waiting for something to come up is check it in a loop instead of just sleeping for 30 or 60 seconds and going, hey, it'll come up. Because sometimes it'll take a little bit longer. And then that'll create flakiness. And then the answer is, well, let's just increase the sleeps, and then your tests take longer, and then someone increases the sleeps because it gets flaky again. So it's a never-ending battle. But if you implement a check in a loop, it will, as soon as it's online, it'll start to continue. And then you can have a longer period that it'll wait too, because it doesn't mean it always waits that long. Also, if you're using frameworks like test containers, this has got a lot of the waiting stuff built in, so it'll wait for you and let you know when it's ready. Also, waiting for elements to be present in UI is another area where I see people waiting. A lot of modern test frameworks, though, do this for you, so they'll handle a lot of this. So I'd recommend looking into things like Playwright for UI testing framework if you're using something old like Selenium that has a lot of this stuff built in. And this is a simple example with test containers I was talking about. So, this allows you to procedurally build your containers and start them as dependencies for your tests within the test itself. So an example here, we've got this, new Postgres build. This is part of the test containers library. It does this start async. I'm missing my await in the example code, sorry. But then this will wait until the Postgres database has started, the port is open, and it's ready to receive connections. So it won't continue onto this line until you've got a container online. So you don't have to put in sleeps or waits or anything like that. It also does some other nice stuff, like you've got this nice get connection string method. So there's no more maintaining JSON configuration for your tests. So this is quite nice, I think. So if you're not using test containers, I'd check it out. End-to-end testing is not a good solution in general. So if you are standing up large amounts of infrastructure to run your tests, then this is a problem. Ephemeral infrastructure that we spoke about before helps, but it's not a savior. I really love this quote from Cindy from Copy Construct. I'm more and more convinced that staging environments are like mocks. At best, a pale imitation of the genuine article and the worst forms of confirmation bias. It's still better than having nothing, but works on staging is one step better than works on my machine. So let's talk about mocks versus end-to-end testing for a minute. So when we talk about mocks, just a bit of a disclaimer, I'm generally talking about HTTP mocks. You can also get other kinds of lightweight imitations. You also may have ones that are using gRPC as opposed to HTTP if you're building on that flavor. It could also be a mock in code too. Sometimes these are nice mocks, but generally this is what I'm talking about. Most of the time it's HTTP mocks when we're using them. So the difference between using a mock and a real system. So one of the problems with mocks is that you can create a mock of a system and then the real system over time changes, and they may introduce somewhere along the line a breaking change that isn't reflected in your mock. So all your tests are passing, you look good, then something gets deployed to production that breaks your system. And this isn't necessarily contractual breaking changes. It could be functional breaking changes as well. So the data contract may be the same, but because the underlying values that it's returning are changing, it may do something that breaks functionality in your system. But the only way to make sure that things work end-to-end, though, is to test all systems. So I'm not adverse against end-to-end testing. I think it's a necessary thing. We just need to work out a better way to do it. So mocks, in summary, mocks are super stable. Like if you're using something that is a pure HTTP mock, it is so dumb and has so little moving parts that it is super stable. The problems with that is that the mock can get stale. That is. So how do we validate that the assumption in our mocks are still correct? That's the question we've got to answer. If we want to use mocks, we need to be able to validate the assumptions. And also, when we change a back-end system, that conversely means that we need to validate all the mocks that have been created of it when we change it, which may be a huge amount of mocks, depending on how many consumers you've got. So the other way we can look at this problem, too, is if we're using mocks, hey, what about we publish a set of mocks from the back-end system? And then consumers can use mocks that we know the back-end system has validated and has the right behavior. This means two things, though. It means that the back-end system needs to be aware of all of its usages, which is generally fine if it's got a low number of clients. and it will be ultimately responsible for breaking changes that impact other systems, which again is generally fine if there's a low number of systems. So a good example of where, I've seen this successfully work is with BFFs. So with a BFF, you generally got like one or two clients. A good example is, I've seen BFF used for mobile apps where it's got two clients, Android and iOS. And it works quite well because you know your consumer, you know all of their use cases, it's simple. And generally, when you're changing one, you're changing the other at the same time. Where it becomes problematic, though, is if you have a large number of consumers. This becomes hard to scale. It means you need to put a lot of knowledge of how your consumer uses your API into the API. So this is where consumer-driven contract testing helps. So if you haven't checked this out, I definitely recommend it. Basically, the Pact Framework is an implementation of consumer-driven contract testing. It's not about testing contracts, though, although it will test them for you. Most of the languages that I use are statically typed languages, so your compiler tests the contract. When we talk about contract in the context of Pact Framework, though, it's also talking about the functionality, the data that's returned and things like that. So the way Pact works is you essentially have a Pact contract which can produce a mock and a test. And to build these, sometimes you can, it's a nice flexible framework. Sometimes you can start with the mock, generate the contract and test, or start with the test and generate the contract and mock. So essentially you have a test that is kept in sync with the mock that can then be used to run on a back-end system to validate the assumptions in the mock. So how this works in practice is if we have a look at our system under tests and the mock, the back-end system that we're using, it consumes the published tests that come from the mock to validate the assumptions, and it'll fail its pipeline if the back-end system makes any changes that would then break the consumers. So how this works at scale, if we try and scale this out a bit, you essentially end up with end-to-end testing being populated, but it being isolated and distributed into pockets. So each system uses mocks to mock their downstream dependencies, publishes tests downstream to the dependencies to then run to validate the assumptions in the mocks. And it also means if a back-end system makes a breaking changes, it'll probably break its pipeline that would then be used. And you can also, the Pact Framework allows you to link things together too. So you can do things like if you're changing a mock in a consumer, before it publishes that mock to be assumed as the latest Pact contract, it would then trigger a pipeline in another system. So you can keep things in sync that way and prevent consumers from publishing things that will break other people's pipelines. Know your test framework. So this is a problem that I had recently. We started to use Playwright for the first time, and one of the problems we ran into is there was a bit of our documentation that actually got out that instructed people to use this thing called network idle. And network idle, you can see here in the Playwright documentation, is they basically say don't use this. So, and we had a lot of test flakiness get introduced because people were using this, because they looked at the documentation and said, oh, they're using network idle, I'll use that. It must be like the good default option. And we got quite a few tests that were published that caused quite a bit of flakiness from this one little thing. And for us, it was just a matter of like, if you're implementing something, you spend some time to understand it deeply, or get some expert advice or training, or hire some expert people, especially if it's new technology. I mean, Playwright is very new. So key takeaways: monitor your stability, avoid end-to-end testing. Sometimes using production as a dependency in testing is okay. Like, don't be afraid, but be careful. Ban retries, know your test frameworks, question all usages of sleep in your test, ban them too in most cases, and check out test containers. I think it's a really cool framework. That's it. So I hope you guys enjoyed that and got something out of it, and please hit like and subscribe. And I'll put some links in the description if you're interested in some of the things I was quoting. Thanks.